Okay, let's just finish up these last two examples here. So looking at this one, D, these are separated by subtraction and they are different bases, so there's definitely nothing we can do to simplify them first. We need to evaluate them separately. So first things first, I convert them to radical form. This negative is not part of the exponent, it's not in brackets, so I'm going to leave it outside and convert 225 to radical form. So the denominator is 2 of the exponent, so it becomes a square root. So it's the square root of 225 all to the exponent 3. Over here I have the square root of 16 all to the exponent 3. So square root of 225 is 15. Square root of 16 is 4, so I get 15 cubed and 4 cubed. Once I evaluate those, I can simplify to get my final answer. E is a little bit trickier. There's a few ways of going about it. What I did first is I took everything that had negative exponent and then just moved it to the other side. So if, for example, 25 to negative 1.5, move that to the denominator so the exponent will be positive. I took 125 to the negative 2 over 3, brought it to the numerator, so now that would be a positive exponent. So I did that first. And then I noticed that because I had exponents that were decimals, I preferred to try and convert those to fractions. So I recognized that 1.75 was equal to 1 3/4, which converts to 7 over 4. And 1.5 is 1 1/2, which converts to 3 over 2. So I just changed those decimal exponents to fractions. Once I had those, then I could start trying to evaluate them. So I converted all of these three to radical form. So again, remind yourself, denominator of the fraction becomes the root, and then the numerator becomes the exponent that goes outside the root. So I had so for this one here, I had the 4th root of 625 to the exponent 7. Then I had the cube root of 125 all squared, and the square root of 25 all to the power 3. Now, it just so turns out the 4th root of 625, the cube root of 125, and the square root of 25 are all 5s. So it simplified down into this, and then I used some grade 9 exponent laws. So I added the exponents 7 and 2 because there was multiplication going on. Then I subtracted 3 because of the division. So I got 7 plus 2 minus 3 gave me an exponent of 6, and then 5 to the exponent 6 is 15,625. Okay, so there's definitely a lot going on in that particular example there. Okay, so we're going to try some more complicated expressions with rational exponents coming up in a later lesson, but I want to switch gears a little bit and actually look at trying to solve exponential equations. So when I say exponential equations, I mean equations involving exponents. So let's say we have cube root of x here equals 5, and we just want to solve for x. So we haven't worked very much with cube roots before this year, but let's just say if I had given you a question where we had the square root of x being equal to 6, well, your instinct to try and get to try and solve for x, try and get x by itself, would be then to square both sides of the equation. Okay, so you'd take this side of the equation, square it, this side of the equation, square it, so you'd wind up with just x now on one side of the equation and 36 on the other. Okay, so it's a very similar idea that we're going to use over here, except now we have a cube root of x instead of a square root of x. So how do we get rid of a cube root? Well, we take it to the third power. So if I have the cube root of x here, I'm going to take this all to the power 3. I'm going to do that to the other side of the equation as well. Okay, so 5 cubed becomes 125. Okay, cube root of x all cubed just becomes x, so you get x equals 125. Okay, if you want to think of this in terms of using rational exponents instead, you could have rewritten the left side as x to the 1/3. And then you could think to yourself, okay, I just want x to the 1, not x to the 1/3. So if I could somehow multiply that fraction, that exponent, by 3, I could get x to the 1. So how do I multiply it by 3? Well, I take it to that power. So I have x to the 1/3 to the power 3, 5 to the power 3. Because then 3 times 1/3 here simplifies to give you x to the 1, or just x. Okay, so two ways of thinking about that one. Okay, looking at B, I have x to the exponent 5 equals negative 32. And just the best analogy I can think of for earlier questions that you would have had is, let's just say we had x squared equals 49. Okay, well, you have taken the square root of both sides of the equation. You told me that x is equal to plus or minus 7. That would have been after taking the square root of both sides. So over here, it's the 5th root, it's x to the exponent 5, so let's take the 5th root of both sides of the equation. So I'm going to take the 5th root over here, And I'm going to squeeze it in here, the fifth root of negative 32 as well. So fifth root of x to the 5. I'm just going to show you the intermediate step. You wouldn't need to write this down in a test, but this would be the same thing as having x to the exponent 5, all the exponent of 1 over 5. Okay, so when you multiply those exponents, 5 times 1/5 gives you 1. And the fifth root of negative 32 gives you negative 2. So you get x equals negative 2. Okay, I want to point out here that with the fifth root here, you don't get plus or minus as an answer. It's only going to be one answer, negative 2. Okay, reason being, if you're trying to solve the equation where, let's just say we had x to the fifth equals 243. Okay, there's only one possible answer, okay, because 3 to the fifth equals 243. Okay, but in this case, negative 3 to the fifth does not actually work. Okay, that would actually equal to negative 243, so negative 3 is not a valid answer to this equation. Okay, so there'll be one answer, x equals 3. You're only going to ever use a plus or minus when you're taking even roots in an equation. Odd roots like 3, 5, 7, and so on and so forth will only give you one answer. One like this one, when you have x to the fourth, well, what you're going to do with both sides of the equation here is take the fourth root. So if we take the fourth root over here, and the fourth root of 81, the fourth root of 81 is actually going to be, when you're solving this equation, you're going to get plus or minus 3. Okay, because the way you want to think about it, if we had this equation, x to the fourth equals 81, 3 to the power 4 equals 81, which we all know. But because it's an even exponent, if we did negative 3 to the exponent 4, that negative would now become positive, so you get positive 81 as well. So again, just to recap here, when you're solving an equation and you have to take an odd root, you're only going to get one solution. If you're taking an even root, that's when you use the plus or minus like you did when you're solving quadratics. Okay, a few others to try and solve here. So again, just trying to solve for x, I have the seventh root of x to the exponent 5 equals 243. What I'm going to try and do here, really there's two things that I need to undo. I need to undo the seventh root. I need to undo the exponent of 5. So I'm going to do it step by step and then show you a little bit of a shortcut afterwards. So first thing I'm going to do to get rid of the seventh root is I'm going to take the seventh, each side to the seventh exponent. Okay, and that seems like a perfectly reasonable thing to do. However, if you try to do 243 the exponent 7 in your calculator, you're going to run into a big problem. The number is so big, it's not going to fit on the screen. So we can't write it out, we're going to lose accuracy. So that approach isn't going to work. So I'm going to erase that. Didn't like that. And what I'm going to do is I'm going to rewrite this. Instead of 7th root of x to the exponent 5, I'm going to rewrite it as the 7th root of x, and then put the exponent of 5 outside. Okay, and again, since the order I do the exponents doesn't matter, we can do this. And then what I'm going to do first to get rid of that exponent 5 is to take the fifth root of each side of the equation. So I'll take the fifth root of all that and the fifth root of all this. So when I take the fifth root of the left side, the only thing that's left now is my 7th root of x. When I take the fifth root of 243, I get 3. Okay, so this becomes a much more manageable number to work with, because now what I can do is get rid of that 7th root by taking the 7th exponent to each side. Okay, so I'm left on the right side, left side of the equation with x, and on the right side I have 3 to the exponent 7, which gives me 2,187. Okay, so this way worked reasonably well. So I had to do it in a couple steps, right? I had to get rid of the exponent of 5 first by taking the fifth root, and then I took had to get rid of the 7th root by taking the exponent 7 on both sides. What might be a potentially faster way that I'm just going to show you over here is I'm going to rewrite my left side of my equation as a rational exponent to begin with. So I'm going to rewrite that as x to the exponent of 5 over 7. Okay, and remembering that what I need is to just have x to the exponent 1 on the left hand side. That's how I'm going to get x by itself. Well, if I think about what I would need to have multiplying 5 over 7 by to get 1, well, if you're trying to multiply a fraction by something to get 1, you're going to be multiplying by the reciprocal. So if I take the reciprocal of 7 over 5, the reciprocal of 5 over 7 is 7 over 5, I'm going to take that exponent to both sides. And what this is actually going to do is do both the steps that I did on the first method over here, but I'm going to do them all at once. So if you look here, the reason I chose 7 over 5 for the exponent, if you multiply these together, the 5's cancel, the 7's cancel, so you're just left with x. So the only thing I really need to do is then evaluate the right-hand side of the equation. So this will give me now the fifth root of 243, okay, all to the exponent 7, and then I can get to my answer. So fifth root of 243 gives me 3. 3 to the 7 gives me 2187. So do two different ways of going out to get the final answer. I think the way on the right is a little bit faster because again it does both methods of simplification in one step. Okay, one last one to look at down here. This one's a little bit trickier. You're trying to solve for x here, but you got other things going on now. Now we have a coefficient on the square root, and we also are subtracting 6 as well. So what we want to do with this is try to get it to look like one of the ones we've done before, and that's going to involve trying to simplify it a bit first. So what I'm going to do here is I'm going to start by doing a little bit of grade 9 algebra, adding 6 to both sides of the equation. So that'll give me 3. I still have the root of x to the negative 5. And now I'm going to have 96 over here though. Okay, then I'm going to divide both sides of the equation by 3 to get rid of that coefficient. So square root of x to the negative 5 still, and 96 over 3 gives me 32. Okay, so I'm going to try and use the shortcut that I did over here, which is try and put this into rational exponent form and try and get rid of, trying to simplify x all in one spot, all in one step. So I'm going to rewrite this as x. This is going to be the exponent of negative 5 over 2. Okay, so now think, if I want to put both sides of the equation to an exponent to get x by itself, I would need the reciprocal of negative 5 over 2. So the reciprocal of negative 5 over 2 is negative 2 over 5. So I'm going to take both sides of that exponent. Okay, and again, you just should do a quick little double check to make sure that you have the right exponent here. So you multiply negative 5 over 2 and negative 2 over 5. 5's cancel, the negative 2's cancel, you're just left with x. So then all you have to do is now evaluate 32 to the negative 2/5, which by now we're probably getting close to being an expert at. So it's a negative exponent. I'm going to rewrite it as a positive exponent first. So I'm going to have 1 over 32 to the positive 2/5. So this will be now 1 over the 5th root of 32 all squared. Okay, the 5th root of 32 is 1. So this is 1 over 2 squared, which is, pardon me, 1 over 4. Okay, so a couple different types of problems there, but again, what we're trying to do again is just to isolate x, doing whatever we need to. So here this is a little bit faster, just to try and take each side of the equation to an exponent, but failing that, you can take the multiple steps here to solve. I just think the other way is a little bit faster. Okay, so that's it. You got some practice here. Also some bonus equations involving exponents to solve for. And going forward, we're going to look at more complicated equations to solve more complicated expressions to simplify. So we'll do that in lesson 25, but for now there's some practice for you.